Let's look at, this is AP FRQ review. Number 1, curve sketching. Number 1 is non-calculator. Consider a differentiable function, so smooth curve, no breaks, no sharp turns. Having a domain in all positive real numbers, and for which it is known that f prime is 4 minus x times x to the negative 3 for x is greater than 0. Find all the x coordinates of the critical point f, and then determine whether the point is relative max, relative min, or neither. So we're already given f prime, so if we want to find anything about relative max, relative min, we can just stay in f prime, find the critical points, set f prime equal to 0, create sign line, and then test the intervals. So here's f prime. I'm going to bring that x cubed back down to the denominator, and we can set the numerator and denominator equal to 0. Remember, critical points can come from both numerator and denominator of f prime. So we set 4 minus x equal to 0, we get x equals 4. We set x cubed equal to 0, we get 0. 0 is a duplicate of the starting point of our domain. So we have 0 here, we have 4 being the other critical point. And now we test our intervals. We can choose 1 to plug into f prime. If I plug 1 in, I get positive over a positive. So positive, I know my function is going to be rising because my f prime is positive. If I plug 5 in, I get 4 minus 5 is negative over a positive, which is negative. So in this interval, my graph is decreasing. So my graph is rising followed by decreasing, which means that there is a relative max at x equals 4. Part B, find the intervals on which the graph of f is concave down. So if we want to achieve concavity, we have to move to the second derivative function. So we have f prime, so from f prime we're going to find f double prime. So to find f double prime, we can go through a product rule, or you can bring the x cubed down and go through quotient rule. Either way. Here I just went through product rules, so f prime times g plus fg prime. Clean this up a little bit. Brought everything back down to the denominator. Combined like terms. Found a common denominator. And then pushed it all back together. So now, once we're down at f double prime, we can find our critical points from the numerator and denominator separately. From the numerator, we get 6. If I set x minus 6 equal to 0, I get 6. If I set x to the 4th equal to 0, I get 0. So again, 0 is a duplicate of the starting point of my domain. So 0 and 6, we choose 1 to plug into f double prime. And we get 1 minus 6. That's negative over a positive, which is negative. So a negative interval for a second derivative function must mean it's part of a concave down graph for the original function. And if I plug 7 in, I get positive over positive, so concave up. As long as there's a change in sign in concavity, we know that there must be a point of inflection. Okay. But this problem is asking about concavity where the graph is concave down. So concave down is where the interval is f double prime is negative, so from 0 to 6, because f double prime is less than 0. Okay. For part C, determine the function of f given f of 1 equals 2. So I solved this using the idea that final position equals initial plus displacement. And I can take the antiderivative. I want to go from 1 to x and replace f of 1 with 2, go through power rule, plug in upper bound followed by lower bound, and we have our f of x function. The other way that some students may prefer is just take the antiderivative of f prime and then solve for c. So here's the other option where we simply move from f prime to f of x by anti-differentiating our expression. So here, if we take the antiderivative, we can expand this out, apply power rule. X to the negative 3 becomes x to the negative 2 over negative 2. X to the negative 2 becomes x to the negative 1 over negative 1. There's a plus c that shows up. We clean up our expression. And then once we have our expression cleaned up, we can solve for c. 1 plugs in for x, 2 plugs in for y. And then we solve for c, we get c equals 3. F of x equals negative 2 over x squared plus 1 over x plus 3. The same results as if we had just gone through this method. So either method is fine.